Hey viewers, Saif exists. Welcome to my channel Guidance Science. Myself Mohammed Saif, and today's topic is why in non-inertial frame of reference electromagnetic radiation does not radiate, or in another way, any charge does not radiate magnetic field or does not propagate magnetic field, because rest and uniform motion are two sides of an inertial frame. That means, first of all, if there is any frame of if there's any frame of difference in the frame of reference of inertia and non-inertial, that means if any difference between inertial frame of reference and non-inertial frame of reference, yes, it is. In inertial frame of reference, the object moving will not require any force to move in it. That means if an object is moving or is at rest in the frame of reference of inertial frame, then it does not require any force to be in motion. It also goes by the first law of motion, that is the law of inertia. That means the body will resist its cause. That means if a body is moving, it will resist to be stopped, or if it's at rest, then it will resist to be in motion. That's all. In inertial frame of reference, it does not require any force to move, or we can say that there is no force acting upon the body. But in a non-inertial frame of reference, there should be continuous force, constant or variable, which should be acting upon the object to change its velocity continuously. By means of changing its velocity means changing its inertia time by time. That means the inertia is not conserved, and thus violating the first law of motion, and thus non-inertial frame of reference. In physics, the non-inertial frame of reference also has a significance, different significance at all, and we will talk about it later on. So why that doesn't happen at all when it's on rest? First of all, I would like to explain you the inertial frame and non-inertial frame. In inertial frame, the position and the time are dependent proportionally to each other. That means the time is directly proportional to the distance. That means the object we should be in a uniform velocity or at rest in all frame of reference that we are discussing. The equation of inertial frame of reference starts with x in the function of t equal to at plus b, where a and b are constant, where a and b could be any number from the range of real numbers. So what does that mean? That means the object could start from any position on the number line, that's x-axis, and could be at rest in all position, or in a stationary, or in a uniform velocity motion at any time in any frame of reference that we are discussing. We can change the frame of reference by changing the value of a and b. And yes, because the values of a and b are infinite, there are infinitely many frame of reference or inertial frame. So okay, now what is non-inertial frame of reference? Non-inertial frame of reference is the frame of reference in which the inertia of the body is not conserved. That means there is a force exerting continuously on that object. It could be a constant force or a variable force. It could be a constant force or a variable force. Then how should we find out which type of force it is? It depends on the situation. That means the position of the body is changing with the directly proportional to the second power of the time or the third power of the time. By changing second power of the time, which means it is directly proportional to the time. That means the velocity is changing directly proportionally to the time. And by cube or fourth power, it means the force is changing continuously, and in the fourth power the work is changing continuously. It's another way by which we could define it, but let it be. Now why the magnetism? First of all, why the magnetism does not produce when the charge is at rest? That has to do with the relative motion. Relative motion is defined as the motion between the two objects. If we are mentioning the magnetic field propagation, then we are mentioning the magnetic field propagation with respect to the charge particle. That means at least we are taking the charge particle as the frame of reference, or the wire, current carrying conductor, as the frame of reference. As you are asking me about the relativity and the Lorentz transformation, I had made one previous video explaining how magnetism works using the relativity and how we can explain the magnetism using the relativity. I will link that in the description, or you can search on my channel by the name Relativity and Magnetism. This is the thumbnail. Make sure to watch that also. Then how does that include all the things which we are talking about? In simple words, then it should propagate relative to one another. Because in my previous video I explained, when the charged body is at rest, the electrons are still moving. But that means that there is a relative motion between the electrons and the charged particle. But now then there is not any force, magnetic force between them. That's because in the frame of reference of the electrons and the ions which are in the wire, the Lorentz transformation is there, but it's cancelling each other. But when the charge is moving, the density of positive charge particle will decrease, because there is a Lorentz transformation only in the frame of reference of the positively charged particle. But in the frame of reference of the ions, it is the magnetic field. So that's we are observing, and thus the paradox arises. So the conclusion: the magnetic field will only propagate if the particle is moving relative to the current carrying conductor. That means if the particle is at rest, then we are approximating that it's at rest, or we are predicting or mentioning that it is at rest with respect to the current carrying conductor. What does that mean? So it means the current carrying conductor moving by which velocity in our frame of reference doesn't matter, but the charged particle is moving in the same velocity and the same direction as mentioned by the current carrying conductor, and thus the positive charged particle could be not stationary with respect to our frame of reference, but because that's the wire which is producing the magnetic field, and within the frame of reference of the wire the particle is in the stationary position, or with the frame of reference of the particle the wire is in the stationary position. So by no means there could be a magnetic field produced in any way. Conclusion: a relative motion should arise between a particle, positively charged particle, negatively charged particle, and a current conductor, so that there is a net relative motion between the two. And some of you may ask, in my previous video, as I had mentioned, the velocity of the particle shouldn't be v, that is the velocity of the moving electrons. It could be larger or smaller, but the relative motion between them should trigger at least a small amount of Lorentz transformation. The small amount of Lorentz transformation could lead to a very high difference between the positive and negative charge densities, and therefore creating a whole charge in it. So if they are not moving in the same velocity, yet they are moving in the same direction, and the difference in their velocity with respect to the wire and with respect to the electrons should create enough positive charge density, like it should make a whole charge or a whole wire negatively charged. That's it for the first concept as we conclude.